So for this assignment, we're asking you to write several different parsers. And we're not asking you to write them fancy. We'll go over how you write some fancier parsers later. These are going to be very simple parsers. So to write a very simple parser, we want to look at the abstract syntax of the language we want to write. In this case, language 0. You see we have literalents and we have pluses. So we know we want to write a literalent parser, a plus parser, and we're going to want to be able to handle a bunch of parentheses. So let's make a parentheses parser as well. All that's going to get wrapped up together in the main parser that we have. So the first thing we want to do is say how we're going to parse ints. Well, maybe we could do an int parser. I actually pasted this in too early, but that's okay. Int parser, if you remember from the myparser library, we've got a nice little int parser ready to go. So we don't have to worry about how that works, or do we? We reload this, you'll see we're getting a type error. So what's the type of int parser? Oh no, sorry, I had something else on me. It's the type of int parser. The type of int parser is parses in an integer, but we want a parser for an AST. This could be a big problem, but we're not going to let it. We're just going to say, we want to get this thing parsing what we want first, then we'll get the types to work. So if we reload, it's actually fine with this. Now, as always, we want to get some examples of what we want this to parse. So, assume I type these in. This is just, these are just some things that we want this parser to work with. Let's just stick them into this parser and see if they work. After I reload, of course. And I save. There we go. First thing parses, second thing doesn't, third thing works. So why doesn't the second thing work? Well, let's experiment a little. Maybe it's the spaces, maybe it's the zeros. It looks like it's the spaces. So how can we get the spaces to work? Well, if we look in our parser library, you'll notice that we actually have a parser, or a function that takes in a parser and eats the spaces before and after. Sounds exactly like what we want. So we've taken an int parser, and now we're just eating the spaces before and after. See if that works. Still parse the first thing. Now I can parse the second thing. Now I can parse the third thing. Wonderful. Now we got to figure out. Now we got to figure out a way to get the types working. So how do we change the type of a parser? Well, again, if you look back, you'll see we have a map parser. Where did map parser find? Map parser. It takes a parser. So we have a parser of integer. Takes a function from integer to the thing we want and returns a parser of that type. Let's try that. I find it nice to put the mapped parsers on another line. We'll see a slightly different style in a couple weeks that makes this less necessary. But in other parsing libraries in different languages, this is a convention I've seen. It seems to work okay. So we're taking an integer, and we're going to go to something we don't know yet. So type check now. It does. So how can we take an integer and go to an AST? Well, remember, the only way to create an AST, because it's a data type, is through the constructors. Which constructor do we want to use? Well, there's only one obvious choice. Let's do literal int I. And now type checks. We're not off the hook though. We should make sure this looks the way we expect. Okay, this doesn't look like it actually changed anything. That's because the show of language 0 is showing exactly what an integer would show. So there's this little trick you can do, but you have to undo it before you run the tests, where you go to deriving show. So we see the whole bulky thing, just to prove to ourselves that this is actually parsing the way we think. And it's nice to switch back and forth, especially when you're working on more interesting parsers, to see the exact syntax tree that you're getting at. Let's do something a little more interesting. I guess we're working, let's do the parse parentheses. Let's come up with some examples. We want to be able to parse things that look like this. We want to parse things that look like this. We want to parse things that look like, let's go crazy. Things that look like this. We want to parse things that look like like that. So once we've got a sense of what this thing's supposed to do, let's again, let's just try to take in the literal open parentheses. How can we parse the exact string open parentheses? Well, if we look back to the library, we can use a literal to do that. And then we want to do something else. And remember, it's 3 pluses for parsers. And then we want to do something else. It's going to be probably like this. Now, I say this a lot, and I'm going to keep saying it. Always reload your REPL, see if you've made a mistake. In fact, we have made a slight mistake. This type doesn't match this type. So let's just ignore the type signature for now. Is it okay so far? It's okay so far. So it makes sense that we would want to put everything that parses in here, like this. Of course, the problem is we're not done with the parser yet. So this isn't going to really, we haven't really done anything. This is still undefined. So another trick that I really like is to stick everything you have done in here with a note that you're not done yet. Now we can try our parens parser on our examples. That's no good. I mean, we got the first thing, but we have some issues here. Let's deal with the first thing. So the reason is that this parens parser needs to be worked into the parser to parse more than one thing. So to do that, we say we're going to parse a literal int parser, or we're going to parse parens. That doesn't quite work. We got the wrong type. So how do we get this? We've got an either AST, and we want just a regular AST. Well, this is too hard to deal with for now, so let's deal with that later. Let's only concern ourselves with parsing things with 1 parentheses, and then we'll deal with that in a bit. So this 2 plus 5 isn't going to work yet because we don't have the anything parsing pluses set up. And I gave you some misleading examples. We should always try to throw some random spaces in there. Make sure that works. Sorry for the typos. Okay, so you'll notice that we're not doing spaces correctly. Let's fix that right now. We can just stick a token around these two literals. Now if we reload, you'll see that we can parse both the spaced and the unspaced. Now, let's fix the type here. One trick I really like is to copy and paste the type. Sorry, let me back up there. So, we want to map, but this thing is kind of crazy. And we don't, how are you going to match whatever this thing is to this? Well, you don't have to think it through. You can be very, very brain dead and just copy it straight out of here. It's just the first part of the tuple. And it matches the pattern match exactly. So we're parsing in the literal open parentheses. We don't actually care about it. We're parsing in literal int. In that case 1, we actually care about the entire AST, so let's capture the entire AST. And we don't care about the closing. So how do we get the inner AST? Well, it's just that. Now we can do this. Now we can go back to what we originally were worried about and get the parser to parse more than, to get the parens parser to parse more than one thing. Let's go here. Problem is that these have the wrong type. They're not getting an AST. So again, the answer is, I find it very helpful to go in 2 separate stages. Get the thing to parse first, then map it to the correct thing. Get the thing to, put the things together, and we'll map it to the correct thing. Actually, maybe we should do that in a little bit, just so we do it when we're all the way done. We should try our examples again, just to make sure they work. Let's try to get the plus parser working. Now, here's the key. We're only worried about fully parenthesized expressions, so we'll just copy this thing, forcing there to be a parentheses here. It's a little bit awkward, but it turns out that this makes parsing much, much easier. So we're going to take in open parentheses, something that's going to be on the left. Well, then we better parse a plus. And then let's parse what's going to be on the right. Okay, again, no surprise. The type we wanted isn't this one. Well, let's comment out the type. Okay, all good. Let's, ooh, I forgot my first step. Let's get some examples of things we want this to work for. Let's say, well, everything needs to be parenthesized, so 1 plus 2, 1 plus 3. Oh, let's do 1 plus negative 3. Let's throw some spaces in there. So that parses. That parses. That parses. Oh, wonderful. We got it on our first try this time. So now we need to get the types to line up. We map the parser. Again, it can be very hard to try to calculate this out by hand, but we don't have to. All we have to do is copy this bit from the first part of the tuple, paste it right here, and this is the exact shape of the thing we're pattern matching. So, and the reason I'm doing underscores is just so it doesn't warn us. You could actually leave these things in, since they always parse to exactly the same thing. You never have to worry about it. It's arguably a little more readable that way, but you can do whatever you like. So we know we're always going to parse in a parentheses. Then we don't want to force ourselves to be literal. We want to do the left thing. And we're always going to parse in a plus. Don't care about that. Then we're going to parse in the right thing. Awesome. And finally, we're going to parse in the close parentheses. Let's see, did I do all that typing right? Oh, I did. Wonderful. Now I'm going to combine the left and the right part. Well, AST is the data type. The only way to build it up is the constructors. And you're going to use the plus constructor. Yeah, and let's see if this works. And now let's try our examples again. Let's see if they look like we think they're going to. Examples. Yeah, so 1 plus 3. Got the negative correctly. Yeah. Nice, everything worked. Now we can stick our plus parser right into our final output. Oh, and right. So now the last bit is we combine all the parsers into one big parser. It's important that we put the plus parser first because there's overlap between these parsers, and there's a slight hack where this will choose the first thing. So if we can parse the plus first, we should put it in front. Now we'll notice that if we reload this, we do not have the right type. How can we get the right type? Well, we're going to map the thing. Before we always just had tuples, that was easy, but now we've got something a little bit more interesting. We have a bunch of ethers. So we need to do a case of. There's actually a way to do this inside the lambda, but we haven't gone over that syntax yet, and I don't remember it off the top of my head, so we're not doing it. Well, we know either can be left or right. Oh, and of course, it is my tabs that it's complaining about. So, remember, tabs are awful, don't use tabs. So, we want to unpack ASTs, and it's a little hard to see what the type of A is. So here's a little advanced Haskell debugging trick. If you put an underscore to the right of something, you'll get an error. but it'll tell you the type of everything in scope. So you can see that A is another ether. Where here you'll see that this A is just an AST. So here we're just going to return an AST. I probably should just made it all out, so it's nice to use clear variable names. Right here we've got another split to make. Left. Let's do AST. And right here we can do right AST. That works. And again, let's test our parser against some inputs. Yeah, it just sort of works. You'll notice this is a little awkward. There's actually an easier combinator to do than this. If you think it up and make it, feel free to use it. We'll eventually cover it. If you can't, just pattern match it out. It's a good little exercise. Last thing I wanted to show is if you insert your solutions from a week or two ago for the eval function. Well, that's actually, I believe we're parsing this now. Let's go back to the original show. If you do that, you can run this exec function and put some whatever syntax you like. Excuse me. Oh, well, you have to put the closing quotes, and you'll see you can play around with the little programming language you've made. It's not very interesting yet, but it'll get interesting soon. Let's make a mistake. So, hope that helps.